Hello, my name's David Sprake. I'm Programme Leader for Renewable Energy and Sustainable Technology here at Glyndŵr University in Wrexham. And today I'm going to give a little micro teach, a snapshot of what climate change is in a nutshell. So it all starts with carbon dioxide or other greenhouse gases in the atmosphere. And these have been increasing recently, and the source of how these have been increasing is from burning fossil fuels such as in power stations, coal and gas, and also when we use cars, it all submits carbon dioxide into the atmosphere. And we can see that since the Industrial Revolution, carbon dioxide in the atmosphere has been growing quite rapidly. This is the Keeling Curve, started to be measured in the 1960s. Before then we get the data from ice cores in the Antarctic. And if we can have a look at this data over the last 400,000 years from ice core data, what's startling is the end of this graph where we can see there's a very rapid shoot up to 400 parts per million in carbon dioxide. What we see when we compare this with temperature records over the same period is the carbon dioxide in the atmosphere actually matches temperature, and when the carbon dioxide rises, so does the temperature, and when the temperature rises, so does the carbon dioxide, and those two things are linked and follow each other. And if we add where we are today, the 400 parts per million, then what the whole crux of climate change is scientists are very worried that temperature is going to follow that carbon dioxide and it's going to get very hot indeed. How does this actually work? Well, it's been known about for a long time. Even before the Industrial Revolution, it was predicted that if we increase carbon dioxide, the globe would steadily warm up. And the way it works is that shortwave radiation coming from the sun can pass straight through the carbon dioxide in the atmosphere, and the heat energy is absorbed into the earth. Once the heat energy is absorbed into the earth, it's transmitted out with long wave radiation, and the crucial thing is that this long wave radiation is interfered with by the carbon dioxide. It won't let the heat energy out. So in a nutshell, the carbon dioxide acts like a layer of insulation around the earth that lets the sunlight in, but it doesn't let that heat energy out. So we'd expect the temperature of the planet to start rising steadily if the carbon dioxide rises steadily as it has been. And these are temperature records over the last 100 years or so. And it's over a yearly period for each year. And we can see the temperature records steadily increasing. And it highlights the highest amount as it happened, and we can see that temperature records are being broken all the time, right up to 2014, which was the hottest year ever recorded on average. So we'd expect to see some kind of signs of this happening on the Earth, and this is the Arctic ice flows at the top of the Earth, and this marks the minimum extent of the ice over the summer period over the last 30 or so years. Data is taken from NASA satellites. So why is there any debate over this? You'd think it would be cut and dried. For instance, if 98% of the world's top doctors said that it was very likely that you had cancer, do you think it would be wise to actually do something about it? And we still have some disbelievers, and these are a few articles that have been in the media recently. This one by James Delingpole. He leads the climate change skeptics in trashing the IPCC's sexed up report about climate change. When we see a debate in the media over climate change, normally there's a believer and a non-believer who sit down and have a debate about it for a few minutes, and then they move on. If we had a statistically proportional climate scientist debate, it would look more like this, with 98% of the scientists agreeing and only a very small amount actually disagreeing. And I don't think the media portrays a very balanced view of the scientific community's views. So if we look into the future now, if we carry on as business as usual, pumping carbon dioxide into the atmosphere, these are some predictions that we may get to at the end of the century. And the startling thing about this graph is if we see this proportion of a graph here, That last little jump up before the present day is when we came out of the last ice age, and the difference between the top and the bottom of that little graph there is an ice age, and just that little bit of warming caused us to come out of an ice age. And that's the difference between a kilometre of ice above our heads right now in Wrexham to our present day. And the worrying thing is that if temperatures do follow carbon dioxide as we'd expect, it's going to get very hot indeed. So what is the solution to this? Well, we're going to have to somehow find a way of producing energy without producing carbon dioxide. And there's a way to do it. It's proven technology. It's renewable energies, and instead of using a carbon dioxide fuel such as coal or oil, it uses the sun and the wind and some other forms of naturally occurring events. And the great thing is that once they've actually been constructed, then the fuel for them is completely free for the rest of their lives. And one thing I'd like to point out about this is the big square in the North African desert here. And that represents the area required, that if we filled it with concentrated solar power, that would actually be enough to power the whole world's electricity consumption. So it is absolutely possible to do. The technology is there to do it right now, today. The only thing that's missing is the political will and the investment in it. So if you're interested in this, here at Glyndŵr University we do some BEng honours degrees in renewable energy and sustainable technology. We do MSc programmes and PhDs, and if you'd like to contact me, I'd be happy to answer any questions about my slides or any courses we run here at the university.